Hi, this is again once again let me continue with foundation engineering and or geotechnical engineering 2, and we are discussing right now about stability analysis and of earth retaining wall. In fact, we are still doing earth pressure calculation. I have discussed various theories, how to find out active earth pressure, how to find out passive earth pressure, how to find out earth pressure at rest. Also at the same time, what will be the, because of the active case, active condition, what will be the total thrust on the wall and where it will act, and whatever preliminary theories like Rankine's and then Coulomb we have discussed, and what are the advantage and disadvantage of the both the methods we have discussed also. And we have taken few problems in the previous lecture, and today I will also take a few more, and then after that I will try to explain how to do the stability analysis. Stability analysis means what? When you design a wall, means design means what? Actually, what should be the height and what should be the base width, what should be the top width, whether it is a gravity wall, whether it is a cantilever retaining wall or something else. And based on that, again if there is a particular wall, if you design, that means suppose a 5 meter height or 10 meter height with some dimension, and if it retains particular soil, then it may, whether it is safe or not, that to be verified. How to verify that? It is general mechanism is to we have to find out that various failure modes, and then you have to check each mode how much factor of safety. So, that I will come later on. So, before that let me discuss about a few more problems, and the first problem let me take that a retaining wall with a smooth vertical back is 8 meter high and retains cohesionless soil, soil backfill. Location of water table is at a depth of 3 meter from the top of the wall, and calculate the total active thrust on the wall if the horizontal backfill carries a uniform surcharge load of 30 kilonewton per meter square. Also calculate the line of action of the lateral force from the base of the wall. The unit weight of the backfill is 18 kilonewton per meter cube and angle of internal friction is 30 degrees. So, that means this is a problem basically I have to do, suppose this retaining wall is suppose some height, actually it is mentioned something like this, and it retained backfill, level backfill, water table at 3 meter height. Then calculate the total active thrust on the wall if the horizontal backfill carries uniform surcharge now of 30 kilo. So far whatever problem we have considered, there was no surcharge. Now we will be giving surcharge of 30 kilonewton per meter square, something like this. Okay. So, this value is 30 kilonewton per meter square. So, this is the additional thing, and this water table and all those things we have discussed before. So, let me take a new page and try to solve this problem, and you can see now the problem was it was 8 meter height wall, 8 meter high wall, and it is a level backfill with surcharge. It is 30 kilonewton per meter square and at 3 meter depth water table. And so, first thing actually you have to calculate the your gamma t is given as 18 kilonewton per meter cube, gamma t equal to 18 kilonewton per meter cube, and your K A will be, if you calculate K A equal to 1 minus sin phi by 1 plus sin phi, and phi equal to 30 degree, if you put, it will be 1 by 3. And so, now we can draw pressure diagram one by one. So, I will draw from here, suppose it is 8 meter, suppose this is 8 meter high, and then I will draw the pressure diagram. First of all, earth pressure diagram at up to 3 meter depth, because of this soil pressure So, this is the pressure diagram. So, this value will be 18 multiplied by 3 multiplied by 1 by 3. So, this value will be equal to your it will be 3 get cancelled. So, it will be 18. So, somewhere I have written, and then you will have because of the water table here actually the pressure diagram will be changing from here to here, and so this 18 will be remaining. So, that means this one is 18 and we have to find out this one. So, this one will be equal to 18 minus 9.81 multiplied by this will be 8 meter. So, 8 minus 3, so it will be 5, and so this will be equal to 13.65. Okay. So, this is 13.65. So, this is because of the soil we have drawn. Now, because of the surcharge I have told you that it will be throughout the depth, it will be constant, that value will be equal to, so it will be K A times Q. So, that will be 30 multiplied by 1 by 3, it will be 10. So, it will be a 10 kilonewton per meter square. So, I can divide it to, this is 1, this is 2, this is 3, and this is now 4 actually. So, if I divide it 4 parts, so then I can find out P 1 will be equal to half multiplied by 18 multiplied by 3. So, it will be 27. And what about y 1? Y 1 from here to here. So, this will be 5 plus 1 by 3 of 3. So, it will be 6. Similarly, P 2 will be equal to, it will be 18 multiplied by 5. So, it will be 90, and y 2 will be equal to, actually y 2 will be up to middle of this. So, this will be y 2, this is y 1. So, y 2 will be equal to 5 by 2 equal to 2.5. Similarly, P 3 will be equal to this triangle. So, this triangle will be half multiplied by 13.65 multiplied by 5. So, this will be equal to 34.125, and y 3 will be 1/3 of 5. So, it will be 5 by 3, and P 4 will be equal to this diagram. So, it will be 10 multiplied by 8. So, it will be 80, and y 4 will be how much? That means from here to mid height of the area. So, that will be y 4, that means this will be equal to 8 by 2, that means 4. So, total active thrust P A will be equal to P 1 plus P 2, P 1 plus P 2 plus P 3 plus P 4, and if you add them, then it will become sorry, I have missed one more, because of this water table there is supposed to be another water pressure, and that will be equal to 5 multiplied by 9.81. So, this will be P 5 will be 5 multiplied by 9.81. So, that will be equal to suppose 122 point, no. So, P 5 will be 5 into 9 okay, multiplied by half multiplied by 5. So, that will become 122.625, and your y 5. So, this is suppose 5, I gave this is 5, y 5 will be again 1/3 of 5. So, it will be 5 by 3. So, plus P 5, if I add them together, then it will become 353.75. And now, if I want to find out the point of application, that means ultimately where that active thrust will act. Suppose this is P A acting and this is height from here, suppose y A. So, that means P A multiplied by y A equal to P 1 y 1 plus P 2 y 2 plus P 3 y 3 plus P 4 y 4 plus P 5 y 5. And if I put all P 1 y 1 P 2, it is all listed here, P 1 P 2 P 3 P 4 P 5 etcetera, all if I put here, and then on P A also here already I have got 3.75, then y A will be equal to, ultimately you have to calculate, and then it will become 968.25 divided by 353.75, this is P A, and then you will get a value equal to, you can say here that value will be equal to 2.737. So, these problems perhaps I have taken before, that means only water table except this one, then the problem will be ended here and this P 4 will be missing. And when there is a surcharge is there, level surcharge of uniform intensity, then we know the pressure, active pressure will be uniform, which will be equal to K A times Q, and that will be throughout the depth, it will be same intensity of pressure will be there, active pressure. So, you have to find out area of that, then you will get the total thrust because of this surcharge, and then if you sum all those, then you will get total thrust, and then you take moment with respect to that point from the base, then I will get the y A like this. Okay. So, this is about the first problem. Let me go to the second problem. Second problem is again let me you can say this is the problem. So far we are discussing the problem about the active earth pressure, and when it become instead of active, if it become passive or something else, there is no difference, except you have to calculate K P, and which is nothing but 1 by K A, that is straightforward. That is one thing, and you have to, while finding out the pressure, active earth pressure over the depth, when it is active pressure, we have multiplied by K A multiplied by the vertical pressure, and when it will be passive case, you have to do what you have to do, I have to multiply by K P with the vertical pressure. So, with that actually I can complete the earth pressure diagram. Once the diagram is done, the diagram will be whether it is active and passive, whatever may be the situation, ultimately thrust will be equal to area of the diagram. So, I will take this problem now, that is passive case instead of active, and you can see this that. So, this problem actually you can see that an earth retaining wall 4 meter high supports a backfill with horizontal top. Okay, that means the backfill 4 meter and it is horizontal backfill. So, it is the backfill ground like this. The wall is pushed towards the field. So, as definition, actually what we have done, that when the wall is pushed towards the backfill, then it is a passive, and when the wall moves away from the backfill, that is active, and when it is pushed toward, this is passive, and when it is no movement, that is at rest. So, now in this problem it is mentioned the wall is pushed towards the backfill. So, because towards the field, that means this side by some means, because of some reason. So, it is pushed towards this. Then if you do that, then compute the total force on the wall just before the failure. That means, if I push, if I give little push, passive pressure will be there. You further increase the push, still passive pressure will be there, but pressure maybe will be increasing. Then if you further increase like that, it will pressure will be increasing, but at some stage that instead of further increase, the soil will fail. So, that means that full passive condition, what is the maximum, that is at the full passive, when the full passive condition will achieve, that time we will get the total maximum pressure on the wall. So, because of that, so that means so it is mentioned compute the total force on the wall just before the failure. That means it is pushing, but pushing means just pushing is not enough, but if I push enough, then it will achieve a failure, and at that point what is the maximum pressure, that is what you have to find out. So, if I want to do this, and then we require what properties of the soil, that means here actually C, so far we have done actually cohesionless soil, that means without any C value. Here the soil is having value of C equal to 25 kilonewton per meter square and phi equal to 20 degrees, and degrees is missing here, you can put, and gamma equal to, equal sign also missing here, gamma equal to 18 kilonewton per meter cube. So, this problem let us do with step by step. So, I will do like this. Suppose a 4 meter high wall, level backfill, and we know that it is a Kp condition, that means passive condition, since it is moving towards the backfill. So, Kp will be equal to 1 plus sin phi by 1 minus sin phi, and the phi value is given here 20 degrees, and if I put this value here, this value comes 2.04, Kp value comes 2.04, and when the soil, when the wall retains C phi soil, then we know the active pressure passive pressure at any depth P will be equal to gamma H K P plus 2 C root K P. So, this is the formula we know. That means, with the depth, increase of depth, with the increase of the, so this is H equal to 0 here and H equal to 4 meter here. So, you are increasing this direction. So, when H equal to 0, then your P will be equal to 2 C root K P, and that value if I calculate K P value root if I take, and C value if I put 25. So, it is 50 multiplied by under root 2, and this value comes approximately 35.7 kilonewton per meter square. So, that means I will get a some value. So far when we are drawing the earth pressure diagram, we are getting 0. Now, instead of 0 we are getting some value, and now if I put H equal to some value, any value, we can see that suppose H equal to 2 meter. So, it will be equal to gamma is actually is 18. So, 18 multiplied by 2 multiplied by K P actually 2.04 plus 2 C root K P, this will not change. So, that means it will be whatever it will be. So, this calculate this one plus this one. So, it will be value. So, that means this value is constant. So, it will be constant. So, this will be constant, and because of this will be increasing linearly like this. So, if it is your height is 4 meter, then it will become, so when H equal to 4 meter, then your P become 4 multiplied by 18 multiplied by 2.04 plus 35 point, or that means actually 2 C root K P, and which is nothing but 35.57. So, this is 35.7. So, this value when it is there, so these two, so this is actually should be this one, and this should be this one. So, this entire value is this. So, this value is constant. So, that means this portion is your this one. So, this is actually your, if we calculate, it comes 146.88, and this value is 35.7. Now, what if this is the earth pressure diagram. So, earth pressure diagram for passive case, and this passive case, now I can again divide into two parts, this is 1 and this is 2. So, now I can calculate P 1, that is passive, or P P 1 I can say here now P P 1. So, that will be equal to, because of the rectangular diagram, that is actually 35.7 multiplied by 7. So, that will be equal to not 7, it is 4, that will be equal to 142.8 and y 1 that will be equal to mid height. So, this is y 1. So, that will be equal to nothing but 4 b divided by 2 equal to 2, and similarly P p 2 I can find out. P p 2 will be equal to half multiplied by 146.38 multiplied by 4. So, that will be equal to your 293.76 and y 2 will be equal to 1/3 of this is, if it is y 2, then that will be 1/3 of 4. So, that is 4 by 3. So, your that means total P p will be equal to P p 1 plus P p 2, and that will give you actually P p, that is 436.56 kilonewton. And now, if I want to find out what is the thrust, where the thrust actually acting. So, somewhere here suppose it is acting, and that is at a distance suppose y a or y p suppose, then P p multiplied by y p equal to your P p 1 multiplied by y 1 plus P p 2 multiplied by y 2. If I do this and all values are known, P p 1, P p 2 are known, y 1, y 2 known. If I put those values, then y p will become 142.8 multiplied by 2 plus 293.76 multiplied by 4 by 3 divided by that P p is actually 436.56. So, if I calculate this one, then you get 1.55 meter. So, that means this is a passive case. So, whether it is passive or active, the calculation is similar. That means, first of all you have to draw the earth pressure diagram, and if it is a cohesionless soil, earth pressure diagram will be varying from 0 to linearly to a maximum value at the bottom of the wall. There will be a triangular diagram, and when it is a C-phi soil, then you have to remember the pressure equation for active and passive pressure in terms of C and phi, and for the passive pressure this is the equation gamma h K p plus 2 c root K p, and if it is an active case, then it could have been gamma h K a minus 2 c root K a. So, since it is a passive condition, so we have taken this diagram. Initially I put h value is equal to 0, then what is the value at the surface, what is the earth pressure, then we increasing the h we have got the value, and then at putting at 4 meter, putting h equal to 4 meter, I have got the maximum earth pressure at the bottom. Now, this diagram you can see is a diagram become a trapezium, but instead of using the whole trapezium, I can if you remember the CG of trapezium, I do not have any issue, but we easily remember rectangle, triangle. So, because of that I can divide into two parts, one rectangle and one triangle, and then I know the CG of them, and then I can find out the area of them. Then I have calculated area of the first diagram, I have denoted as P p 1, area of second diagram I have written as a P p 2, and CG of their those diagram also I have given as y 1 y 2, and P p will be equal to P p 1 plus P p 2, that also I have done. And finally, to suppose to resultant acting as a distance y p, then P p multiplied by y p will be equal to P p 1 multiplied by y 1 plus P p 2 multiplied by y 2, and putting all those value, finally I get the y p equal to 1.55 meter. Okay. So, this is not new, it is same thing. Okay. So, I will go back to the next problem. Suppose your third problem. You can see this, this is a problem also I have discussed, and when it is a active case, and then the pressure diagram is, you can see a vertical cut when a C-phi soil or in a cohesive soil, then I have shown that that at the surface generally it will be tension, particularly when it is active case, because in the active case wall will be like this, wall moves this way, and when wall moves this way, when it is a sandy soil, then it will flow but when it is a cohesive soil, it will stand up to some time, but at beyond some movement it will crack will form. So, that what is the depth of crack, maximum depth of crack, that we have discussed theoretically, and also we have discussed what should be the maximum depth up to which we can excavate without any support, which is nothing but double the depth of crack, and we have done that. So, now this problem actually I will try to show that, and you can see here that a vertical cut in a purely cohesive soil failed when the depth of cut reached to a depth of 5.1 meter. What is the expected value of the cohesion of the soil? Assume unit weight of the soil is 20 kilonewton per meter cube. And so, wall is something like this, and not wall, actually the soil is there and we are excavating suppose like this, and after some depth of excavation soil failed, and we know that theoretical depth of excavation without support, actually we know what is the depth equation. We know actually when there is a C5 soil and we know the depth of crack, suppose this is the soil, depth of crack, we know the formula actually if you dc or yc, if I say, that was 2c by gamma root Ka. Okay. And depth of excavation dE, depth of excavation without support will be twice of yc. So, that will be equal to 4c by gamma root Ka. How it came actually? We know the pressure at any point actually gamma h Ka minus 2c root Ka. So, where cracks forms, there actually pressure will be 0, initially pressure is negative and then it is decreasing and becoming 0. If I put this equal to 0, then I will get h equal to, or h equal to, you can say hc, which equal to 2c by gamma root Ka, and which I have written as yc, and this is actually, that means twice of that, up to the tension curve is 0, the twice of that actually you can excavate without any support. So, because of that, depth of support excavation without support is twice of yc, actually 4c by gamma root Ka. Now, we can see that this depth is given. This depth is given actually when it is become 5.1 meter. Let me so at 5.1 meter it failed, and which can be equated to 4c by gamma root Ka, and we know that it is purely cohesive soil. When C is a purely cohesive soil, that means phi equal to 0, and that means your Ka become 1. So, if I put this one, this equation will be reduced to 4c by gamma. So, 4c by gamma equal to 5.1 and gamma is given actually 20. So, C will be equal to 5.1 multiplied by 20 divided by 4. So, that will become 25.5 kilonewton per meter square. So, that means sometime the problem will be C value, phi value, everything will be given. One may ask you that what is the depth of unsupported excavation, then use this formula, this will be in that case HE, and then with this formula put the value of C, put the value of gamma, put the value, then we will get the value. Here actually problem is asked in differently, that while excavation it failed at 5.1 meter depth and it was seen that soil was purely cohesive. So, what is the expected value of cohesion? So, that actually that means I have just back calculating, I know the depth, I know the gamma, I know the Ka, then what is the value of C. So, by putting this equation I get the value of depth equal cohesion equal to 25.51. So, this is the problem actually. So, third problem, and with this I will just stop here, and in fact I will in my next session I will try to discuss about the stability, and that how to analyze the stability, that means how to find out factor of safety against suppose overturning, sliding, bearing capacity, all those things I will try to find out in the next slide, next session. Okay. Thank you.